Okay. Yeah. Okay, thank you everyone. I hope you enjoyed your lunch. We'll kick off again with our session 2, technology and innovation. Technology and innovation have built the wind industry to what it is, and we'll keep on building it forever. So we need to understand what's going on. And of course, we're now in the age of AI, which introduces a whole new dimension of complexity, which we will also look at. So that's our session 2 is going to be devoted to that this afternoon. And before we have our first panel, I'm very pleased indeed to invite Christian Wood, who is Executive Vice President, Renewables and Ocean Structures Digital Solutions at DNV, to join us on the stage for a presentation. So, Christian, please come on up, and the stage is yours.
Good afternoon. Hopefully you can all hear me. I can hear myself. So, hello, yes, my name's Christian Wood. Disclosure, I work in the software part of DNV. So I build software for engineers, and what I'm going to do in this presentation is not labor so much on the wind technology per se. The knowledge density for that in this room is really high. I'm going to focus on how AI is going to influence us over the next 5, 10 plus years. So, with that, we have been in the age of computers for quite some time, and the age of computers really changed things for us. People went from doing a lot of paper, mandrolic exercise in their heads or on paper, and started to digitize that. That made it more portable, made it more consistent, etc. Then along came the internet, came along globalization, come along unlimited scale, the cloud. That changed things. That allowed work and information and data to move into lots of different places. And then, when it came to doing work, we could source it from all those different places. Next, we step into the AI era. And with the AI era, what we get is, rather than work being done on pen and paper, computer, desktop, we get a very different paradigm, where work that was done mandrolically can start to be automated contextually. So going from internet and scale, those things give us the opportunity to take work that was stepped through in desktop and user interface paradigms, but with people driving, and more of that can be passed and handed to the computer. So what I'm going to talk about next here is how this changes in the context of engineering and the software products I build, but the context here can be switched to almost everything. It can be switched to financial. It can be switched to the insurance world, project management. To be honest, every administrative task that we currently do today, be it communication, coordination, parts of those things can be offloaded onto AI. And what does that do to everyone? So I'll take it through in this context. So, ever since people were doing these kind of calculations for wind or offshore, we've had our expert, our user. In our engineering context, they stepped through a set of workflows. And when that started, this was on pen and paper and in head. Over time, computers bore the brunt of some of this. Some things were automated, some calculations produced, and perhaps in these little silo buckets that I've got here, people build up their workflows and tasks, and people get streamlined at it in a sense. But even today, people are in desktop computational tools. They do pockets of this, and they finish one thing, they get on to the next, and there is months, weeks, months, sometimes years to complete these tasks. Conceptually, what does AI bring into this? And I bring this symbol here to represent the agent, an AI agent. And wherever you can describe a job description or a methodical process or set of tasks that take context, turn it into information or decisions in this workflow, you can conceivably automate in small, discrete chunks. Not the whole thing, say, but in small, discrete chunks. Then you orchestrate it. You give it an orchestrator, a prime agent, and a user. You give it access to a lot of data, context data templates, and conceivably you can workflow enhance. So the original user will take a baseline of being kind of a 1x user. You start automating along these lines, and each person that is in the team can conceivably do things at a 10x level of productivity. That means it's what requires a team of 30 today might require only a team of 3 tomorrow, or scale inversely. But we know that there's lovely deterministic elements of this, but AI is a probabilistic process, which means hopefully lots of the time it gets these things right, occasionally it gets it wrong. And what we cannot compromise in this setup is trust in the quality of what's being produced. So as much as there's energy into workflow enhancement in this world, there needs to be just as much energy into quality and trust in the solutions as well. And that means agents that are vigorously checking what is being done, the quality of it, are there any warning signs, red flags, bringing the human into the loop, but also version control, quality control, and linking what's coming out into kind of a repository type space. So conceptually, the AI will give us a productivity leap that we've not seen before for a very long time, potentially making each person 10 times more productive and effective than they are today. What does that look like in practice? So it could look something like this, whereas previously people were in desktops clicking buttons for weeks to months, we could be talking about hours to days, maybe up to a week, in discussing in a chat, LLM-style interface, something we're all very familiar with, connecting that to an agent workflow that delivers on the type of work that we're doing. And this context is switchable between all of us in this room. The second thing, it gives us an opportunity to increase confidence. Whenever we're doing engineering modeling today, and this engineering modeling could be various other types of modeling in all of our different approaches, you have simple models, you could have advanced models, and then you might have the best computationally detailed thing available to you today. It takes way too long, unpractical most of the time. And we use a lot of simple models and we use a lot of advanced models today. And what does the computation around AI do? Well, first of all, it's giving us access to a lot more computation. And with a lot more computation, we can do the more advanced stuff. That's one thing. But actually, the other part it does, technologies like physics-informed neural networks can take the simple physics of today and give that an extension. It can give it an enhancement. What it can do is to say, okay, we've got the simple physical basic calculations here, and what we can do is instead of having an empirical model bolted onto it, like a curve or some kind of simple surface, we can actually give it a hyperdimensional neural network that is able to represent rather complicated physics in a much simpler calculation. So it gives us more confidence in the calculations we can do, as long as these things are done with quality, they're vetted, maybe certified even, that we trust them. So it can increase our confidence and extend our capabilities. The third thing, and this happens to everyone in the room, and particularly in my context, it's going to increase demand. And what do I mean by increased demand? So electric vehicles, we've got circa 50 million on the road today. By kind of 2035 or 2030, we should have 200 million, and it'll be well beyond that a few years down the line. Massive electrification demand increase. One nearly as big, or in fact actually I think it's marginally bigger, is space heating and cooling. Space heating and cooling is going to add a massive lump to the demand of what we need for this room. And then last but not least, data centers. And if we were to look at data centers in a North American context, it's huge. It looks like a kind of, in 2040, there's going to be 16% of all electrical demand in North America will be related to data centers. In Europe, perhaps a little bit more modest, something in the realms of 3%. But considering it is below 1% today, it represents a tripling. And this is only a guess. So when we add all those together, 2035 Iberdrola's estimation, our DNV ETO says 2040 we expect 55% global electricity demand increase by 2040. So all of this represents an absolutely colossal opportunity for us in terms of the productivity, the quality gains, the increased confidence it can give us, but also it goes straight back to the demand that stimulates our industry. So what are the challenges? And I think this is one of the big challenges here. We have got to get both temporally where the energy is produced to, from supply to demand. And that's geospatially, so as in we've got to transport it across distance, and we've got to transport it temporally, because often where we produce or when we produce it is not the same as when it's consumed. So big challenge here, and that needs creativity. So we need everyone in this room and your stakeholders and your teams to start leveraging creativity to find the synergistic solutions, to find the solutions that allow for kind of curtailment resilience, that allow for kind of projects and industrialization to kind of get the kind of the scale that we need to achieve. And lastly, we need to find those opportunities to take the technologies we know have great promise, and we need to de-risk them, and de-risk them through industrialization, standardization, and also make sure that we're collaborating more deeply, because none of us is an island, none of us can do it alone. This is an industry and societal challenge, and we need to treat it as such. So, what I want to leave you with is we've got an opportunity. It's massive. It is based on productivity. It's based on the demand creation that this can give us. Lean into AI, and we should be able to seize that opportunity before someone else does. Thank you.
Thank you. Okay, thank you, Christian. There we have it, AI. It's with us, and we're going to dig in a little bit more to it in our next panel, hopefully at some stage. But let's introduce our next panel. What are the next technology game changers shaping wind power? It's a big area to discuss, but we've got some great people to do it. I'd like to welcome them up onto the stage. We have Lucy Craig, Senior Vice President and Director of Growth, Innovation and Digitalisation Energy Systems at DNV. Please come up, Lucy. We've got Stefan Buller, Head of Offshore Portfolio Management and Floating Wind at Siemens Gamesa. We've got Ricardo Roca from BayWa. He's the Technical Director, Offshore Wind, and is Managing Director of BayWa RE Projects Portugal. We have Alfredo Pares, Senior Vice President and Head of Renewables at Hitachi Energy. We have Murthy Pazumarthy, Vice President Technology and Head of Cetrium Marine and Deep Water Technology. And last but by no means least, Adriana Verde Rios, Senior Vice President and Regional CTO, Northern and Central Europe at Vestas. Adriana, please join us. Right, you're all very welcome. Thank you very much. So technology game changers. So what we're trying to do here this afternoon is we're just trying to get a glimpse from all the perspectives we have. And we have some people in lots of different parts of the wind industry who are going to give us a perspective on how they see technology driving things forward over the next year, 5 years, perhaps even longer. I'm going to start with Alfredo from Hitachi. Alfredo, welcome. Grid technologies, storage technologies, nothing's going to happen to the wind power that we all produce unless we can get these technologies right, unless we can integrate them with wind power at the right scale, in the right place, and using the right technologies. So, Alfredo, give us a glimpse from your perspective of the key technologies that are coming through, and maybe also some of the challenges that you're facing in getting them deployed at the right scale, in the right places, at the right time. So over to you.
So thank you, and thanks for putting grids first in the agenda. which I think is probably one of the right things to do. So in terms of technologies, what do we try to achieve here? Different aspects. You can think about bringing more power from one point to a point, power density and capacity of installation to bring that power. We can think about power system stability. So we bring a lot of power electronic-based generation, which is affecting the network. So you can think about those elements, no? And that's where technology comes to play. Power density, so we're talking about higher voltages all around, whether it's in a collection grid or is in a grid connection, whether it's AC or DC, and we see all those things happening. New Frontier 132 kV for a collection grid. On the AC side, size of the substation reaching the gigawatt. On HVDC, the 2 gigawatt connection that is being the new standard for the large transmission system. So we're getting there in terms of power density, you know. In terms of integrating and stabilizing the power, here we are in the world of power electronics and digital, no? That's what's going to make the difference. With technology like FACS, STATCOMs, that will help us. eSTATCOM, no, we combine the power electronics with the storage capability, active, reactive power combination. So all these give us more tools in our toolbox to address the new challenges we do have, no? And all this then combined with digital. So it's a glimpse of things that are required, and not to make it too long, too complex. Then what is stopping us for implementing those? I guess there may be different things. The first message probably is to say, technologies are there. So it's not that we're missing new tools in our toolbox to reach 2030, 2035. That's the first message I would like to get it clear. And if something is missing, we have time to scale it up as we scale up the whole industry and the whole ecosystem. So technologies are there. What we need now is adoption, no? So that those who have to invest can take the risk, can invest in these new technologies. And here we can think about TSOs who have their own framework, their own mandate, and probably there could be a challenge here to say, well, can I really adopt the latest technologies that are available, no? And I can stop here, not to take too much of the time of the panel. We are here.
No, I mean, this is what we're trying to dig into. I mean, you know, I think you've seen some real life challenges, haven't you? In, you know, you've been asked to kind of speed technologies down the chain, and then you found that when it comes to it, the adoption hasn't happened at the pace and at the scale that you want. I mean, you've actually seen that happen, and that's been a problem, hasn't it?
There will be a driver here, which is the market, no? We all talk about affordability and we all talk about cost of energy. So one of the ways to address it is scale and technology. So technologies are there, available, so that's going to be to help us, to implement those new technologies, for sure.
Yeah, okay. Let's move on to Murthy from Cetrium. Murthy, welcome. So Cetrium is really sort of making a mark in offshore renewables, yeah. And including floating wind. Where are you seeing the kind of game changers coming through, and what technologies are going to inform your journey into offshore renewables as we go forward over the next few years?
Okay, thanks, Anders. Okay, thank you for inviting Cetrium for this insightful event. Cetrium, as you're all aware, is a global engineering solution provider for oil and gas, marine and floating wind and wind sectors also. So currently we have a few projects happening on the substation side. We have more than 10 gigawatt of substation projects happening. So predominantly for the European and the APAC regions. Taiwan is this thing. And from the next couple of years, we strongly believe that floating wind is going to emerge. And then we are getting prepared ourselves for the floating wind side. So we are developing our own in-house designs, and we are talking to many developers on that. We have started the journey 4 or 5 years back on floating wind, where we started with 6 megawatt. So we've done all the studies, we have done it. By the time we finished the 6 megawatt, it's a 10 megawatt game. When we embarked on 10 megawatt, now it's 15 megawatt. We just recently finished the model testing and all of our designs with 15 megawatt. We got the approval from classification societies. Now it's 18 megawatt. So the industry, the technology is going very fast, but at the same time, the supply chain, the industrialization, the factory thing, these are not ready. So what, from our side, the game changers will be, it's key on the supply chain, it's key on the industrialization, it's key on the, even our yards today, we have a lot of yards. We have 15 yards across the globe, Brazil, US, China, Singapore, but our yards, we are trying to make them ready for the floating wind market. So the way of construction of these units itself is the key for us. See, normally we have a various construction methodologies. Suppose the 2 gigawatt one, we are doing the complete construction in Singapore and Indonesia. We do testing, commissioning, everything. The unit is completed in Singapore. It goes to the location in Germany or Netherlands, finished. But for the floating wind, it's a different game. You can't construct and complete it in Singapore. So we have to take it in parts. We have to take it to the location, be it in UK or Europe or wherever it is. Then we have to integrate it. So whether we have the resources there, we're talking recently to a developer there. They don't even have the welders there to construct this actually. So the supply chain, the technology is there, but still, I think it's not ready for the floating wind. We are getting ready for that, and that is where we see. But the key for us is industrialization, digitalization. These are the things which we feel strongly should be coming out actually.
Now, it's interesting because, in a way, your point mirrors Alfredo's, that the technology can be there from a technical standpoint.
Yes.
But the challenges are around scale up and the market being ready to take it at the scale that you need to make it to be cost effective and to make the investments that you need to make. I mean, before we move on, Murthy, I mean, one of your target markets, key target markets, obviously is your home market in Asia.
Yeah.
And I'm kind of interested whether you feel Asia has any particular requirements, any particular special needs that you're looking at in terms of the technologies you're going to bring to the market to serve that region, as opposed to Europe, or is it blanket around the world? Is it?
Okay. Currently, if we see the public domain thing, there's a strong demand saying that from the next couple of years there'll be $90 billion of investment coming into the offshore wind side. And out of that, they say 95% will be coming from the Europe and the APAC regions. So our focus is still in these regions. And the APAC regions, we have Japan, we have Korea, we have Indonesia and also which are coming up. But typically Taiwan, Japan and all, they have their own local content requirements as well. So the thing is, when we do at that scale, we have to be careful of the other regulatory aspects and the local content issues as well, actually.
Okay. Ricardo, from BayWa, I mean, tell us about what you see as the the technology game changers coming through, and I'm guessing that you too are going to be interested in floating wind, so what's happening in floating wind, and how do you see things evolving?
Morning, Zaben. Thanks for having me here. Yeah, indeed, floating wind is in the core of our developments in offshore wind. Although I think that technology's role on floating wind, the way we see it, is on getting advantage of the existing technologies in order to deliver reliable, sustainable and cost-efficient projects. I think that needs to unlock through the execution of projects. That's also something we are missing as an industry, to lift up its project, its credibility, and to understand what is there as a market. And then, of course, it's to bring the existing technology to deliver those first projects in order to give confidence to the players investing in this industry. So technology will need to unlock the existing capabilities in order to maximize the value to the local economies, to the projects, and not the way around. So I think that what we have seen so far in the floating wind space is, I would say, an excess of different technologies, which somehow distract a little bit on the focus of delivery. So I think what we have seen in fixed bottom has been, first projects have been in using gravity-based foundations because it was what was available. Civil contractors, the ports were capable to handle it. It was known, it was reliable. And then, at some point in time, the industry understood that there was a solution that was in use for many years in oil and gas that would fit perfectly, the monopile. And today we have 85% of the installed capacity, and we have a supply chain in Europe that can deliver that technology to the industry. So I think for floating wind, the same thing needs to happen. The projects are the drivers, and they need to be delivered with existing, reliable, cost-efficient, sustainable, as well as economy that brings value to the local economies on the projects.
I think floating for some time, we've seemed to have been on the cusp, and the message has been, we need to make that final leap. I mean, is it? You've explained the technology, how the technology has to evolve, but then is it a matter of scale of deployment? I mean, is that the final element that's going to allow the technology to really prove itself? And why aren't we seeing yet the really big floating wind projects coming through that we were hoping for?
Well, first, because for the projects to come forward, either you have a market where you can do greenfields, and actually in Europe there's only one market where you can actually do that, which is in Italy, or you have centralized tender processes. So you cannot apply to deliver a project if that project is not put on an auction. And that auction might be a lease auction or a CFD auction or both. So the first ones have been done. The first lease auction was done in the UK, ScotWind. It was expected to generate 10 gigawatts of future capacity. It generated actually 20 gigawatts. However, after 1 year, we understood that the grid had no capability to absorb them, so all these projects have been pushed down the line because there's no grid. So then we have first pre-commercial projects in Europe, in France, in Portugal, and then you have the first auction, the first commercial auction that involves, of course, everything, which is lease, auction, and tariff. And since then, you have no more projects. There's no more auctions. There's EO9 coming up in France, and you have, at the moment, close to 23 gigawatts of floating wind projects under development, but which will be delivered late, and you don't have more coming up, so that we can continue working towards our objective. Yeah.
Okay, so yet again we see the relationship between technical innovation at this end of the chain and the policy that's going to pull it through. Stefan, welcome. From the point of view of a big turbine OEM, I'm interested in offshore wind. Where are the technology game changers coming from, as far as you see it, from Siemens Gamesa's perspective?
First of all, sorry. Also, thank you for having me. And the technology development when it comes to offshore turbines a few years ago was only the question, when is the next and even larger turbine coming to the market? But that development, I think, as we all know, that has changed a bit to being able to reliably deliver the technology that we know today. And that doesn't mean that innovation stops. I think rather the opposite is the case. But innovation is just focusing on different things. So we are, of course, now focusing a lot on production, on manufacturing. And there is a huge chance of automating things that couldn't be automated before. simply because if every 2 years a new turbine comes, then there is a lot of manual work and there's a constant change in the factory, and that doesn't help. And now, of course, there is an opportunity to really, let's say, streamline the processes, and not just for us, also for the entire supply chain. And that obviously helps to streamline, to reduce cost, and that is also bringing value. That doesn't mean that we will never see larger turbines. Of course, there's also value in larger turbines, but having this stabilization in product quality, in supply chain, that is a big value, and we wouldn't compromise one with the other. So only if the learning curve is really mature and we make sure that we can transfer learnings to the next technology, we would be willing to step up. And so far, coming to the question, maybe the next technology game changer is nothing fancy. It's maybe just doing more and more reliably and more stable and more automated what we have done in the past. And that, of course, is bringing also huge customer value.
Yeah, I'm interested in your comments on the constant scaling up of turbines. I mean, I think Siemens Gamesa's latest strategy, which was outlined quite recently, is that your 14, 15 megawatt model is your workhorse. That's your key commercial product for the rest of the decade into the market, I think. But you've got a very big turbine testing in Denmark, and I think there was a lot of interest around that. I mean, just tell us what's the thinking behind putting that 21 megawatt machine in place, and what's it teaching us?
Well, that's for sure the aim to commercialize that turbine at one point in time. But we need to be sure that this turbine is as reliable as our existing technology, and we need to make sure that we are not disrupting the supply chain, that we are not resetting the learning curve. Because there is a benefit in going larger, that is also what we heard this morning, but this benefit can only be harvested if we keep the whole process, the whole ecosystem around that, if we keep that stable and efficient. And that is maybe also the mistake that the industry did some years ago, that we were very fast going larger and that we really couldn't stabilize the delivery. And that was hurting us as OEMs, it was hurting the suppliers, and in the end also product quality was suffering, because if you come up with something every second year, of course, once it is getting mature, it is more or less replaced by something new. So this is maybe, it's not either or, right? We are not saying we will never do a larger turbine. You referred to the turbine that is spinning in Denmark, so we are of course collecting experience, and we are making sure that this technology is mature, and we see a value, but that is it's not something we are in a rush to bring to the market.
Okay. So our other big turbine supplier on the panel is Adriana from Vestas. Welcome again. Adriana, talk us through how sort of innovation and technology is shaping the way Vestas thinks about its evolution of its turbines and its wider technologies.
Yeah, so a bit of context maybe before. So until now and for the past couple of decades, it was sustainability driving the wind industry. We wanted more turbines, faster and bigger. Now, when we look at the macroeconomics, we see that investments are shifting from sustainability to defense. And we see that that criteria is losing importance. Well, we see two main criteria coming up, and one is energy security, and the other one is affordability. So when it comes to energy security, we see a huge pull from governments, from customers on how can you deliver energy secure assets. And at the center of that strategy is cybersecurity. I am spending a huge amount of innovation and resources on ensuring that I can provide a secure asset to our customers. Then the other point, that is affordability. This is nothing new. The race for LCOE has been there for the past 2 decades as well, but now it's just taking more importance. And if I take, for example, the example of the German onshore market, we are seeing oversubscription in the audits, resulting in the auctions, resulting in low award prices that put an immense amount of pressure on our customers, which is transferred to us. So when it comes to how do we face and how do we leverage technology and innovation when it comes to addressing these points, and if I focus on the last one, on affordability, of course we're still doing the traditional innovation, looking at new materials, looking at condition monitoring systems. Can we predict failures earlier better? Yes, that is ongoing. But maybe there are two key points that I would like to bring up, and one is modularization. This has been at the core of our technology strategy for the past couple of years. Modularization, it's about leveraging experience and economies of scale and reliability across products and platforms. And we do that in Vestas. We, for example, take our onshore nacelle for the 7 megawatt product. We hook onto the side a standard container that contains all the electrical system of the turbine. Now, that exact same container, if I take two of them and I hook them on both sides of the 15 megawatt offshore turbine, I have exactly the same with double capacity electrical system. Now, this gives me shorter time to market, more reliability for my customers, of course, lower cost, because I leverage economies of scale, right? So that's one. And the other one, I would agree very strongly with Stefan here on that we have a lot of low-hanging fruits on the value chain. There is still a lot of value to gain from standardizing and industrializing the value chain, from the way we transport, the way we install, the way we service. So yeah, those would be the 3 points. So cybersecurity, secure assets, modularization, and value chain.
Okay, thank you. Lucy, DNV, sees the big picture in all these things. Interested on your thoughts on what you think are the kind of technology game changers that are going to shift the dial for wind over the, or indeed, grids. Let's absolutely keep them in the picture over the next few years as we move forward.
That's what I think. The other panelists have all made very relevant comments, and I think particularly Murthy talking about the challenges for the supply chain, because the most visible game changers up till now have obviously been the ever larger wind turbines, and then both Adriana and Stefan have talked about the challenges that brings. And so I think rather than looking at what is the headline grabbing on the larger sizes, there are many other ways in which technology is developing. And so, yes, new materials, lightweight materials, for example, new materials for blades, which will be more recyclable. And that will address a huge problem which is facing this industry if we continue with the current materials for blades for the future. Other areas, offshore wind has been pushing the boundaries for innovation, and of course floating wind there as well, and we see new developments in more efficient foundations, particularly for deep water, so piled foundations for deep water, semi-floaters, ways in which we can enable the floating industry to become commercially viable through reducing costs there. And then perhaps something that's been at the fringe of innovation for a long time, and maybe a shout out here to an ex-colleague of mine actually who sadly passed away last month, and he was a lifelong proponent of multi-rotor turbines, and you'll see in the exhibition floor that there's actually the dual rotor from Mingyang already in testing, and then we've also been working with, for example, wind catching systems, multi-rotor floating technology. So, who knows, maybe that will one day also have an impact on the industry. But actually, there are a number of ways in which the technology can continue to have a huge impact, but Adriana pointed out something that we see all the time. There's continuous improvement in all the many things that we are doing. Yes, in materials, yes, in leveraging digital technology, in the way that operation and maintenance costs are coming down through predictive maintenance, in life extension, and all those many different ways in which the technologies incrementally improving themselves will change the game as well.
Okay, really interesting, multi-rotor turbines. Now, there is a game changer, potentially, that somebody wants or is putting into the market. Let's pick up on that while we've got some experts here. Stefan, multi-rotor turbines. Do you either with your Siemens Gamesa hat or with your expert in the wind industry hat on? Do you see that as a game changer that's going to really shape the industry in the next 15 years or so?
You mean multi-rotor? You mean multi-rotor?
Multi-rotor, yeah.
Yeah, I wouldn't exclude that this could be interesting, but then we are maybe talking the more distant future, I would say. So when you know that we in Siemens Gamesa, we are still supporting the floating industry, but the idea is that we can leverage the scale from bottom fixed in whatever we deliver into floating. That means that the turbine should be as similar as possible to what we are selling on bottom fixed. Of course, there are changes needed. When Melissa Reed this morning said the Equinor started in 2009, that's actually also when we started. So we have 16 years of experience how our turbines are performing in floating conditions. And all of this, of course, needs to be brought into then the technology that we want to bring on floaters. But still, it is very similar to our bottom fixed product. And when I now look at the multi-rotor, of course, this is very different, and as I see the logic of the smaller scale turbines, the industrialization, and so on. But on the other hand, of course, it is still a very small niche, floating at all in general, and it is very difficult to develop something for such a small market. If you can basically hook on the larger bottom fixed market, then it can work. But also when we talk about downwind turbines that are required for some of the foundation concepts,
right,
that will also be difficult because as such, that's of course doable, but for a very small market, it will be a difficult discussion to find someone delivering such a technology.
Yeah.
And this is very much the same also with multi-rotor. So the logic as such, I think, is clear. But it will take time, and I don't think that we are seeing it in this decade.
Okay, interesting. Lucy, just staying with you for a minute, and then broadening it out, hopefully, to what do you see the biggest challenges are, the biggest friction points are in bringing technology through from the lab, from the bench, through commercialization and into scale deployment in an industry like wind power? What are the challenges that the barriers we need to lower?
Yep, and I think there are a few points I'd like to mention there. I mean, obviously the wind industry as a whole is facing quite a challenge. At the moment, we talked about the German market this morning, but if you go beyond Germany, other markets are not looking quite so strong. And that lack of financial stability, that lack of being able to predict the long-term future, that is a challenge for innovation. Who is going to take the risk to test out new technology if we don't have the financial certainty? We know how long is the runway before that can be deployed at scale. And so that financial predictability is absolutely needed. And then we talked also about the challenges of bringing the ever-changing technology, that if every 2 years the platform is changing in scale, that limits actually the speed at which you can really bring technology upscaling to market. And then regulation is a challenge. So Alfredo talked about all the potential that we have in enabling grid integration of wind.
Yeah.
And the technology is there to enable grid support, to provide frequency control, voltage control, grid forming inverters, but the regulations are not there. The grid codes do not really enable wind to contribute in the way that it could.
Okay, Alfredo, your comments on that, welcome.
Yeah, maybe two things I would like to add on top of what you said, Lucy. First, let's think about speed of adoption, no? And then we can learn to Asia and look at Asia and at what speed that market is adopting new technologies. It's something we need to keep in mind, no? So how fast new technologies are being tested and implemented. I think we can do better. But there's another point which I think it's worth to think about. There are some problems we need to address as an industry. So we have our own companies and our own strategies, roadmaps, but there are some aspects of the challenge we need to address that need to be addressed as an industry. And I come with a very specific example, which is the offshore grids and HVDC offshore grids. So in Europe, we have this Interopera project, which I think is a first in its kind, and I like to talk about it because I think we have to be proud of what we are doing here, which is bring the whole industry about figuring out how to build such a DC grid offshore, what is required, what are the functional requirements we do have, what are the contracting models we need to put in place. And the project has delivered the framework, and the next step now is to deliver the first pilot at scale, which will require funds from the EU. So that's a way to address common problems. I think we need more of that if we want really to accelerate the things at the speed and scale we require in this industry.
Anybody else got any views on challenges that we face? Murthy?
One of the key things what we feel strongly is the standardization part actually. If you see from the oil and gas side, there are a lot of lesson learned we have seen from the oil and gas. Initially, there are many drilling platforms and all. So once it comes to standardization aspect, it was stable. So we have to take the lesson learned from the oil and gas and put it back into the offshore wind. That is what we feel strongly actually.
Yeah. Anyone else see any challenges? Yeah.
Yeah, I think that there's one challenge that has not been adopted, and this doesn't mean that I don't believe that innovation is bringing us forward. I just think that as an industry, and particularly in floating wind, there's a lot of reinventing the wheel, and we don't need that. We actually need to make sure that the technologies that have worked on other industries, they can be industrialized into serving a new purpose. Being that from oil and gas, being that from onshore wind. Actually, Christian showed an image that is very dear on me when he finished his presentation, which was WindFloat One. Actually, WindFloat One was a platform that was inspired on what was used in the oil and gas, floating oil and gas business, where we put an onshore turbine, 3 megawatts on top, and it proved the concept, and from that we moved to the next step. As Stefan said, we need to build on experience in order to ensure reliability for the future. And innovation enters there, but if it just comes too many innovations in different directions, reinventing the wheel, then it makes the industry confused and the investors start losing confidence on the industry.
Okay. Interesting stuff, right? I'm going to shift the conversation a little bit onto AI, because I think when we talk about technology game changers, we have to mention it. I just want to do a quick show of hands from the audience, if I could. I mean, put your hand up if you've seen AI deliver a significant change to your business, and I'm kind of thinking above the level of maybe getting Copilot to summarize a report, but you've seen a tool or a process involving AI that's actually made a measurable impact so far on your business. Raise your hands if you have. Okay. I would say that's a minority. I'm going to say about a third of the room, which is interesting, because when we heard earlier, it's here and it's big, and I'm interested to get from our different guests here their perspectives on how they are or they expect to see AI changing their business. Who wants to chip in on AI? Any takers for?
I'll start.
Oh, okay.
Because I'm
Let's start with Lucy, and we'll get on to everybody.
I'm surprised to see only 1/3. I mean, wind has been adopting AI since the past 2 decades, when wind was bidding into markets, and machine learning is the best way of obtaining an accurate prediction of what your wind plant is going to produce over the next half hour, over the next day for the hour ahead and day ahead markets. So AI is not new. What's new, of course, course, is generative AI, is the power of the new technology. And there are many ways that it will change the wind industry. I'd like to mention just one to let others chip in, but we've been working with many of the companies on this panel on wind farm control. So how do you optimize the output of the entire wind farm rather than optimizing only the output from one wind turbine? It's a complex challenge because you have to control many different parameters in the wind farm. And without going into all the technical detail, of course, that is a complex challenge where AI can actually deliver real specific results in production. And also, if we go beyond wind to where can wind bring value, it will be increasingly in grid integration, how it can be combined with storage, with other technologies, and AI will bring the tools that can help us address that complexity. And just final comment before I pass it on, of course, AI is useless unless it is based on trustworthy data. If you have no trustworthy data, then you have no valuable AI. And so you also have to ensure that you have the data and the trustworthy data to make your AI systems work.
Great, thank you. Anyone else, AI? Any other takers? Stefan?
Yeah, just underlining the importance of AI. I think there's not a singular step in our value chain that will not benefit from AI. So, of course, turbine technology development with better digital twin models. Of course, during manufacturing to maybe have a more advanced quality control. Of course, during operation, as you said, market integration, wind farm performance optimization, all the predictive maintenance topics, inspection topics. So there is an endless list, and I think there is really no step in the value chain where you can at least think of the benefits. And I think we are just scratching the surface. We will find much more. So there is for sure a huge potential. And yeah, we have just contracted computing power just a few days ago, and yeah, it's. I think the sky is the limit here. So we will really see how we prioritize and what we do first, and where the biggest benefits and also maybe the low-hanging fruits are. But this will be a topic to stay for sure.
Okay, very good. Any other takers for Alfredo? Oh, and then we'll get to Adrian, then we'll go to everyone. We'll get everyone who wants to speak. Alfredo.
Yeah, if you allow me, just from a grid perspective, in the age of electrification, there's only one thing that is for sure: the grid will get bigger and more complex. So I think it's a perfect ground for digitalization in AI. So to manage the grid, the rules and the modus operandi we had so far will not work. So we need to bring to new solutions, and what we have to foresee now is how we're going to build this autonomous grid. No, so in this growth of digitalization, digital twins was mentioned, how we grow in the technology, there will be a moment where with AI we'll be able to collect so much data, take so quickly decisions that eventually the grid will start operating autonomously. You know? And that's the kind of long-term vision we see and on which we are working on. No? So really a lot of things to discover. We're at the beginning of the journey, but that's one of the orientation we see. We are not going to integrate all the renewables we're going to generate in the future, operating the grid as we've been operating it so far. We saw it in Spain, the blackout. We'll learn more about that, but we can think that the solutions we need, the tools we need to address this kind of new situations we'll have, will incorporate digitalization and AI for sure.
Adriana.
Yes, so I think investors were, of course, as well using it. And as you mentioned, Stefan, it's everywhere on the value chain. I can bring a couple of examples. I think we are still early, I would say, considering the huge value that we can get out of that. We use it, for example, in recommending maintenance, predictive maintenance specific operations for our technician sub-tower, which has resulted in a measured increase of efficiency. We also use it as end-of-line testing of our blades in the factory. We have become much better at predicting failures and removing those failures before the blade leaves the factory. Also increasing the efficiency in our operations almost by half when it comes to blade testing. But I mean, this is just the beginning. I would, for example, love to see AI playing a role in pairing turbine operation to dynamic electricity prices in the market as one of the examples. So huge potential here.
Yeah, that seems to be the theme. Sky's the limit, huge potential. Anybody else?
Yeah.
Murthy?
I think we see across the value chain AI has impact right from the yard side or the design or engineering side. We see more than 30 to 40% of reduction in the engineering value chain. Like a small example, when we do a floating wind design, when we do a coupled analysis, we have to do 10,000 different scenarios to put it wind, wave, current with the turbine thing. So now we are trying to implement AI there, and that can really, like a small example, like 7 to 8 months of work can be in weeks' time actually. So we do the model test, we can put it to the AI agent, and that can calculate which are the critical scenarios and give it to us. So I think we see a value there. Digital twins and all predictive, that is definitely on the cards there. Even on the yard side also, we are putting a lot of AI initiatives and all to see how to implement and monitor the thing. Because for us, when we monitor, we have operations across 17, 18 countries, and we have 20,000 workers operating at the same time. So we are using AI to communicate to them and then monitor these things as well.
Yeah. And Ricardo?
Yeah, I think just to add a different perspective, a little bit earlier in the process, before we have assets to operate or assets to build, even earlier than having assets to design, we have the site surveys that determine if a project is viable or not, and determine what is the value of the resource. So that's all a lot of data involved on these assessments, site data, site characterization. I believe AI will have an important role in somehow processing and informing the decision of going ahead with a project or not. So that's a different example.
Well, I mean, look, we've just seen from all your answers the amazing potential I'm sure there is, and we could go around the room and we'd get many more. I'm pleased to say we've got some questions from the audience. So let's tackle these before we end. This is from Richard Van Orik of Seaway 7. Where are we on offshore hydrogen powered by offshore wind? How do we see that? I mean, this was something that was a couple of years ago. I mean, there were some very, very big projects in the works on this. How do we see this evolving? Anyone want to take that one at all? Offshore wind to hydrogen production. Lucy.
Start. Yeah, I mean, of course, hydrogen we are working on as well in DNV. Why has it gone lower down the agenda right now? Cost. So is there potential? Yes, there is. When will it be coming commercial? Not in this decade. And so, yes, there is huge potential when we have excess offshore wind to produce hydrogen. If you look at that whole cycle, it's very energy inefficient. So when can it become economically viable? Basically, when your wind energy is free and you'll be throwing it away anyway, and when your electrolyzers are at a cost also that make that feasible. So yes, we're doing lots of work on feasibility studies. As I say, not this decade to make it come to reality.
Any other views on offshore hydrogen? Okay, let's tackle this one. This is an interesting question. This is from Juan Pereira of Yandanao. Now he's asking, we want everybody to electrify. We want to increase demand for electricity so we can supply it and we can transmit it. But what are you doing in your companies to support electrification of your manufacturing processes? So, in other words, are you walking the walk as well as talking the talk? Anybody got a view on that at all? Any examples we can bring of electrification in the manufacturing process?
It's a good one. The more I think everything is electrified.
That's a tough one.
I'm more concerned about bringing the power to the consumers and see electrification going up. No, but I think definitely we want to live to what our standards and to where we see the world going, and definitely electrification of our own process is a must, and all emission being controlled. Yeah.
I can say that from a developer perspective, we have a concern about localization, so we avoid long transports. We try to have all the production close to the projects. We try to use existing infrastructures, The project should not be the driver for investing in port infrastructures. That should come if the demand is there. The project should be concerned about what they can use from the existing infrastructure and from the existing supply chain into the project's need in order to deliver it in a reliable way. Again, that's our focus, and by doing that, we reduce significantly our, at least, CO2 footprint and try to use available electrified supply chain.
Yeah, very good.
Maybe a very
Adriana.
quick example, in Vestas, we have electrified recently our entire service fleet. We still have one of the regions in LATAM where it's a bit of a challenge because wind farms are a bit far away and we cannot guarantee that we will have charging stations everywhere, but we are working towards that. In all the other regions, that is fully implemented. Yeah.
I've got one final question to Adriana from the audience. I mean, we've heard about Siemens Gamesa's 21 megawatt turbine, and Stefan's been clear that commercialisation is a way down the road. If Siemens Gamesa brought a 21 megawatt turbine to the market, would Vestas do the same?
So this is not the first time I get this question. We will not react, but I do agree with Stefan's message in the sense that the customer wants low-cost electrons in a reliable way. And we believe that the best way to do it, we know because we have done the homework, today we can provide a better, more reliable business case over time to our customers in the 15 megawatt range. There is that. There is the fact that when you increase size, the physics don't scale linearly. So what you are increasing in value, you are doubling or tripling in terms of technical risks because of the uncertainty that brings. Now, that is the situation as of today. So the short answer would be no. But this does not mean that we are not open to constantly evaluate this. And the moment the supply chain is ready, we are more industrialized and we have more certainty, then we can move towards a higher rating.
Yeah, very good. Okay, we've covered loads of ground there. I think you've been fantastic panelists. I hope everyone else agrees. And I'm going to invite you to leave the stage with all our thanks.
Thank you.
Thank you. Thanks a lot. Thank you. Thank you, Stefan. Yeah. Thanks very much. Thank you. Thanks. Right. Right. So, let's move along. We're working through our agenda on technology. And next we have a presentation, and this is from Nexans, who many of you will be familiar with, and we've got a presentation on how the market is driving industrial technology and innovation cycles in the cable industry. And I'm going to welcome up to the podium Sebastian Schick, who's Sales Director, PWR Transmission at Nexans. Sebastian, the floor is yours.
Good afternoon. Thank you very much for the introduction, Andrew. It's a pleasure to be here, and I have to apologize already at the beginning. I don't know if you see the title, it's Wind of Change. I was asked during a presentation for like 10 minutes and be creative with the pitch and should they have good title, and it was Wind of Change, and I was so sorry for it. It's like a bad song. I was asked how the cable innovations have driven offshore wind. And I was reading this question, I was like, well, we didn't make any change in the offshore wind business. It was the other way around, actually. And this is what I want to show in the next couple of minutes to you. So let's see where I have to push. Where is it? This one? Yes. And here we go. I don't need to explain to you what is electrification. For us, this question is very vital because we have never seen ourselves as a participant in electrification, rather a cable manufacturer. I think we just understood 2-3 years ago what it means to be a cable producer and manufacturer, because the market has so changed significantly that we now see ourselves as the big player of electrification, as you are. We are one component of the big network which is changing since years. So I would say today the offshore wind industry has really changed our market the most within the last 20 years. And I have good examples, and I show you what innovation process and product has been evolved from that. But first, what does it need? I really ask myself, and you know that also it needs a frame. It needs some kind of ambition and vision. And we have the same in Asia. I was in Singapore 2 weeks ago, 3 weeks ago, and they have the same mission and they need a frame. And I think this one has unlocked, especially in Europe, significant investment in innovation. Without that, we have done R&D, yes, for sure, but no innovations which are changing the market. And that was one of the reasons I think the industry has changed significantly. Also this, DNV made studies all over the time. Don't believe this number, so you don't need to write them down. But this is our visibility for us as a cable manufacturer, what is happening to us in the next 10, 20, 25 years. And you see, there are big numbers in the room, and all of them are wrong. So maybe it's 300 gigawatt of offshore industry in Europe, maybe it's 450, 490, maybe it's 600, if you compare the different targets. But what is visible is that is a significant demand on energy cables, high voltage, connecting offshore wind farms to the grid. And I'm not counting here also what is happening on the onshore side, which is as double the size of the offshore side. So it's significant. That gives us perspective to do something. Because I was in a room some years ago, it was like 18 years ago, I was much younger, and I was listening to a congress, and there people from the offshore wind industry said, hey, we need someday some gigawatt transport capacity of cables. They need to have this capacity, this voltage, HVDC technology, not mass impregnated, but extruded. And all these engineers in the room said, this is nonsense, no one needs that. We are not mastering this technology. We had no experience in extruded HVDC. The first wave were ABB. And no one said it will happen. And 5-6 years later, especially when offshore wind farm was commercialized, we understood as an industry we need to do something. We do R&D all the time, but innovation normally does not happen without someone asking for it and has a commercial use for it. I think that was also a big learning. We knew at that time we have to do something as an industry. And you see from the timeline, HVDC, extruded technology, started around like 2011, 2012, 2013 to be really more investigated. And I think that was a game changer for the next coming years to come, especially when you look in Germany. But I'm saying this technology and innovation will also bring so much impact on what happens outside Europe in the next coming decades, especially on the Asian market. Examples here, 320 kV was qualified in 2015, and at the same moment was commercialized. What you see today happening in Germany is also very uncommon. We have a qualification in 2025 kV, which was happening around 2019 and 20. So it was a big innovation, a product. But guess what? Nothing would have happened if there wouldn't have been in 2023, 2024, market players, stakeholders believing in this technology. And without that commitment, like the big TSOs in Germany saying, yes, we are buying this kind of product, we're believing in this technology, not even knowing if it works, would have not happened. So I want to just give you here an example that innovation is not happening by itself, but is really a commitment of the whole industry of offshore wind, and without that it would have not happened. So what are we currently doing? We are building, executing projects on a high scale and high level of innovation, which we'll see and come to life in 2028 the first time. So we turn on the plug and hope it works. So also very interesting approach, time to market, very long. We cannot wait because otherwise all the offshore wind industry will not run. We will miss the targets, the European targets, the national targets. So I think it's a chicken and egg problem, and we solved it somehow with all the stakeholders involved. And also here this numbers, 70 gigawatt to reach. I mean, that's a lot of transport capacity needed over the next coming decades. What has been done, also to give you an idea, it would not have happened if the offshore wind industry is not there. We, as a whole industry, are ready HVDC 525 extruded. There are some other solutions. I will come on my last slide saying what is happening in terms of innovation, because they are happening much more. But there's a huge expansion. Only looking at Europe, we have today much more cable capacity in the market. You all have seen 2-3 years ago, you could read in the press, we have not enough capacity, we cannot execute everything. I think the wind turbine manufacturers have had the same. No, we have enough, we just need time and we need a schedule. We cannot turn on the switch and expect that the industry delivers also innovation. We did a little bit plan ahead. And I think at least for the European countries and EU, it is given. We have a framework, we have a plan, we have stakeholders who have the money and they can execute this project, and then it will run. What we also see, the production, the installation assets. Installation assets has also been really a shortage. So who's laying the cables coming from manufacturing side to a vessel? We don't have enough. What we see today, that there are many vessels ongoing and being built. So it will double in the next coming few years the capacity. So here's no bottleneck. We have the right product, we have the right equipment, the production means in place, so it will fly. What next? I really like what has been said on the panel here, because I think it's not a solution, one solution like a cable. It's about seeing the overall scope and the value-added chain. So this is also what we are seeing. What we see is more links, more necessity to repair, to maintain, to have services in place, reducing the risk profile of a project, because this is it. We don't want just a low LCOE for the wind turbine investors. We also need to reduce the risk and help them to manage it. That means we have repair services, we have the people who can make joint repairs, we have to be reactive, so we cannot wait. A critical link, today we have like 100 critical links. In 10 years, 20 years, it's more than 1,000. So just by statistics, you can say, okay, we have every year some events, and this needs to be repaired quite quickly, and not in 4 or 5 months, but rather in 3-4 weeks. And this is what we are working on optimizing really the whole value-added scope here. Monitoring, I've seen outside, something we have started in 2013 also working on, very important, but not only the cable and ambient, it's about other monitoring systems which can also supervise everything which is related to this overall project. What are we working on in the cable industry? Floating wind industry, bringing a lot of new challenges to us as a cable manufacturer, new cable technologies, flexible cable technologies, different system setup, converter technology change. So this is all impacting our cable design basis. We also see not only HVDC technology changing, but we also see 400 kV plus HVAC with midpoint compensation, having 80 kilometers, not HVDC, but HVAC, this will come. No? Not only because there's a bottleneck on HVDC, it's also making maybe sense in terms of overall CapEx optimization and TOTEX. So this will come. Bigger cross sections, more energy transmitted into 3,000 square mil copper today is not unusual, absolutely not anymore. I think maybe it's going to 3,500, 4,000. So this follows really a strong industrial investment also, because you cannot use the same machines, you need new equipment, heavier load systems, so there's a lot to happen. Dry versus wet designs. So today everything is wet design in terms of cables, dry design in terms of cables. In the future, we wet designs, reducing weight, getting rid of lead, for example. So we are doing continuously R&D in this segment. And I don't know if this ever comes to life in a commercialized way. Superconductivity is just one example, but I would always say these kind of things are more try and error things. They need to validate itself in trial projects. 525 HVDC should have been a trial project actually before, but it has been commercialized and ready to market. Superconductivity will be tested in France in the near future maybe, when the financial figures are okay and feasible somehow. So this is maybe also changing a little bit the opportunities which we have in the offshore wind farm industry. So for me, it was important also to outline which are enablers for innovation and for a business like offshore wind to evolve. It's a long-term agenda by politics, a regulatory framework, very important. Without it, it will not flow. You will not invest. The revenue models must be in place. You see in the auctions which happen in Germany, they're showing if this happens, everything has a delay of 1 year. Everything is delayed, and this is also very bad for us as a cable manufacturer. We need to plan, we need to have capacities in place, we need to hire people and engineer. And last but not least, and this was also one big message, if we work as a development community strategically together, and this is what we're doing, so we're talking with converter station manufacturer, with offshore OEMs on the wind turbine side, I think this can unlock additional potential innovation, not only in our house, but in the whole segment of the industry. Thank you.
Thank you, Sebastian. Okay. Okay, thank you, everyone. Thank you, Sebastian. And it's time for another break. So please go and enjoy some coffee and resume at 3:10. Thank you.